Okay, let's continue our job and discussing continuity part 2. Still, we are speaking about continuity at a point, but now we will discuss, let's remind ourselves about the condition of continuity. We said we have three conditions. Limit exists, the function is defined, and they are equal. And as we said, we can summarize it in f of x is continuous at x equal to a if and only if limit when x goes to a from left should equal to if at a equals to limit when x goes to a from when we satisfy either condition, that will be fine. Example number 6, here it says find let the constants k and m if possible that makes the function continuous everywhere. So if we look at this question, we have minus infinity to plus infinity, that's everywhere. We have from -1 to 2, we have the function m times x plus 1 plus k. And if it is more than 2, it's x squared plus 5. If it is smaller than -1, it's 2x cubed plus x plus 7. Now, we should say first, we don't have a problem for the function in each piece is continuous definitely in the interval minus infinity to -1, union from -1 to 2, union from 2 to infinity. It's continuous in each piece. Now we need to speak about at x equal to -1, I need to satisfy three conditions. So I will say f of x is continuous at x equal to -1 if I satisfy the condition limit when x goes to -1 from left has to equal to f at -1 has to equal to limit when x goes to -1 from right. Now I need to calculate 1, 2, 3. So I will say the first one where I want to find limit when x goes to -1 from left, my function should be going to -1 from left. My function is 2x cubed plus x plus 7. When I substitute -1, get -2 -1 plus 7, which is 4. The second condition, the second part in the condition says what is f at -1, the value of the function at -1. When x equal to -1, you need to replace x here. So again, it will be -2 -1 plus 7, which is equal to 4. The third part of the condition is the limit when x goes to -1 from right, and when x goes to -1 from right, here we have -1 from right, so our function is m times x plus 1 plus k. When you replace m by x by -1, you will get m -1 plus 1, which is 0, plus k, which is equal to k. So these three informations will give me what? Will give me 4 must be equal to k. Now, what about, so we said that's the first condition, that's the second, the third part, we should say f of x is continuous at x equal to now 2 if and only if same thing limit when x goes to 2 from left must equal to the value of the function at 2 must equal to limit when x goes to 2 from right. Again, that contains, let's say, A, B, C. So we come and calculate what is A. We need limit when x goes to 2 from left. Limit when x goes to 2 from left. Left of 2, it will be m times x plus 1 plus k. K, we already find it out to be 4. So when you substitute 2, you will get 3m plus 4. B, I need the value of the function at 2, and it says here, when x equal to 2, you need to replace it here. So if I replace x is 2, I will get 3m plus k, but k already found. C, what's the limit when x goes to 2 from right of the function? When I go to 2 from right, it is x squared plus 5, which is 2 squared plus 5, which is 9. So we conclude from these three conditions, 3m plus 4 must be equal to 9, which means 3m must be equal to 5. Then dividing by 3, we get m is equal to 5 over 3. So the values of k and m, which makes the function continuous, it's k equal to 4 and m is 5 over 3. Now, next example, it says find the value of k that makes the function continuous now at -4 only. So all what I need to say here, what I have, this is -4. It before it's k over x squared. After it's x squared plus 4. So we should say f of x is continuous at x equal to -4 if and only if the limit when x goes to -4 from left has to equal to f at -4 has to equal to limit when x goes to -4 from right. So again, I have 3 parts, 1, 2, 3. So we should say here, when I have limit when x goes to -4 from left, that will be limit when x goes to -4 from left, it's k over x squared, which is k over 16. The second, f at -4. F at -4, when it is equal to -4, it will be -4 whole squared plus 4, which is 20. And the third condition, limit when x goes to -4 from right of the function. Limit when x goes to -4 from right, the function will be what? X squared plus 4. So when you substitute, you will get again 20. This means applying this condition, the first one we get, it's k over 16. Second and third, we get a 20 multiplied by 16. So k is equal to 16 times 20, which is 320. This value of k will make the function continuous. Similarly here, he wants the function to be continuous at 1. So we should say f of x is continuous at x equal to 1 if and only if limit when x goes to 1 from left should equal to f at 1 should equal to limit when x goes to 1 from right. So I have 3 parts, 1, 2, 3. So the first one will say limit when x goes to 1 from left. If 1 means smaller than 1, smaller than 1 means 2 minus x cubed over k. When you substitute 1, you will get 2 minus 1 over k, which is 1 over k. The second, we need f at 1 and f at 1 when x equal to 1 again, it will be 2 minus 1 over k. I get 1 over k. The third condition, limit when x goes to 1 from right. So limit when x goes to 1 from right means more than 1, so I will have root of 2x minus 1 minus root x divided by x minus 1. We need to multiply by the conjugate to remove the root, so it will be root 2x minus 1 plus root x. And here again, don't forget the bracket is a must. So that will be equal to limit when x goes to 1 from right, square of the first, it's 2x minus 1, minus square of the second, which is x. So that will be x minus 1 times root 2x minus 1 plus root x. So that will be limit when x goes to 1 from right. 2x minus x is x minus 1 divided by x minus 1 times root 2x minus 1 plus root x. So these will cancel. When you substitute 1, you will get 1 over 1 plus 1, which is 2. So it's 1/2. So applying the condition, applying this condition, we calculated the 3 parts. The first one gives me 1 over k. Second one is 1 over k. The third one is 1/2, which means k must be equal to 2. 1 over k equals to 1/2 means k is equal to 2. Now, here we have x between 1 and 2. If x is smaller than 1, it's absolute value of x. If it is more than 2, it's x squared. So when he say find the value of a and b, which makes the function continuous everywhere, we should say first f of x is continuous on minus interval minus infinity until 1 union 1 to 2 union 2 to infinity. We don't have any problem with this one. The second condition, we need to say f of x is continuous at x equal to 1 if and only if the limit when x goes to 1 from left equal to the value of the function at 1 should equal to limit when x goes to 1 from right. And means we have 3 parts, 1, 2, 3. We need to calculate the first one. What is limit when x goes to 1 from left? That will be limit when x goes to 1 from left. What is our 1 from left? It's absolute value of x, so it will be 1. If at 1, what is the value of the function at 1? It says again, you need to say absolute value of 1, which is 1. Third, limit when x goes to 1 from right. That will be limit when x goes to 1 from right. 1 from right, it will be ax plus b. When you replace x by 1, you will get a plus b. So the 3 parts here implies when they are equal means a plus b must be equal to 1. That is the first equation we get. Now, the third things we need to say f of x is continuous at x equal to 2 if and only if limit when x goes to 2 from left must equal to f at 2 must equal to limit when x goes to 2 from right. So again, I have three conditions, A, B, C. So I need to calculate what is A, limit when x goes to 2 from left, limit when x goes to 2 from left. Our function is 2 from left, it's ax plus b, which is 2a plus b. Second, we need f at 2, what is it? When x equal to 2, we need to replace it here. So it will be 2a plus b again. C, we need limit when x goes to 2 from right. So limit when x goes to 2 from right, this is 2 from right, we have x squared, so it will be 2 squared, which is 4. So these three conditions will give me 2a plus b must be equal to 4. Now we need to solve these two equations, 1 and 2. Equation 1, we have a plus b is equal to 1. Second equation, we have 2a plus b is equal to 4. If I multiply the first equation by -1, I will get minus a minus b equal to -1. And if I add it with 2a plus b equals to 4, I will have, this will be 0, 2a minus a will be a, 4 minus 1 will be 3. So a is equal to 3. Now replace a in any equation. I have a plus b is equal to 1, means 3 plus b is equal to 1, which means b will be equal to -2. So the value of a and b, a is a 3, b is -2. Now, the last question in this part, we want to find the value of k that makes the function continuous at 1. So here what we have, this is 1. Before 1, it's x cubed minus x squared plus 2. At 1, it is equal to 2. When it is more than 1, it's 3k square root of x plus 1 minus k times x squared. So when we say f of x is continuous at x equal to 1 if and only if limit when x goes to 1 from left must equal to f at 1 must equal to limit when x goes to 1 from right. So I have 3 parts, 1, 2, 3 need to be calculated. So the first one, what is limit when x goes to 1 from left? So limit when x goes to 1 from left. What is 1 from left? It's x cubed minus x squared plus 2. So 1 minus 1 plus 2, which is 2. Second, f at 1. What is f at 1? It's 2. Third, limit when x goes to 2 from right. Limit when x goes to 2 from right. 2 from right, it's 3k square root of x plus 1 minus k times x squared. So when x goes to 2, you will get 3k. Sorry, when x goes to 1, not 2. when x goes to 1 from right. Okay, if x goes to 1 from right, I will get square root of 1 plus 1 minus k1 squared. So we get 3k plus 1 minus k, that is 2k plus 1. Now applying the condition now, the first one gives me 2, the second is 2, the third one it's 2k plus 1, which means 1 is equal to, if you take 1 to the other side, so you will get 1 equals to 2k, which means divide by 2, you will get k is equal to 1/2, so it makes the function continuous at 1. This will end up our discussion for continuity at a point. Thank you for listening, Bart.